Previous approaches of emission control are not capable of meeting the new requirements. The next viable step in reducing peak combustion temperatures and therefore reducing emissions is to cool some of the exhaust gas, mix it with fresh intake air, and move this mixture into the combustion chamber. This process is known as exhaust gas recirculation, or EGR. The mixture of recirculated exhaust gas and fresh intake air is referred to as the charge air. The extra exhaust gas in the charge air is inert. This means that it has virtually no oxygen in it. Therefore, it will not burn. Also, some of the heat energy during combustion is absorbed by the inert exhaust gas instead of the fresh air, thereby reducing peak combustion temperature. This reduces the formation of NOx while minimizing the use of retarded timing. Pressure inside the exhaust manifold needs to be increased. This is accomplished through the use of either a variable geometry turbocharger, an exhaust throttle orifice, or other restrictions. Details of their operation will be covered later in this program. When commanded to do so, the EGR valve opens and allows more exhaust gas to flow. The gas then flows through the EGR connection tubing toward the EGR cooler. The recirculated exhaust gas then enters the water-cooled EGR cooler, where its temperature is reduced. The cooled gas then continues to flow through the exhaust tubing to the intake side of the engine. On the intake side of the engine, the recirculated exhaust gas enters an inlet mixer. At this point, the compressed fresh intake air coming from the turbo is combined with the recirculated exhaust gas to form the charge air for combustion. This charge air then enters the intake manifold and then the combustion cylinders.